Okay, this is the last part of the last question of the paper. And it says, sketch a phase portrait for the general solution to the system of coupled differential equations for this, right? So again, look, this definitely isn't an easy question, but it's not like one of these like crazy, impossibly hard questions. If you look at my videos, I go through how to sketch all these phase portraits for the different types that you can get. And when we have two negative eigenvalues, and we have our solution. So these are our eigenvalues, these are our eigenvectors, this is the solution that we got, and these are the derivatives that we got from part D. There's a particular way to sketch the phase portrait. So the first thing we need to do is draw in these eigenvectors. So I'm going to draw them into the plane here. So -2, 3. So -2, 3, just kind of go to -2 approximately here, 3 approximately here, and then draw a line through 0, 0. Let me just continue up here a bit. Make sure that's straight. Okay, so that's the eigenvector -2, 3, and then I draw the eigenvector 0, 1. So 0, 1 is just going to go in this direction. So it's just going to be straight up the y-axis here like this. Now, because the two eigenvalues are negative, what happens is the solutions, and we said, guys, it was a stable, 0, 0 was a stable fixed point, so it's going towards, it is going towards 0, 0. So the solutions go towards 0, 0, which means this is actually going to be a sink. Okay. That's the first thing, so that you get 1 mark for that. The next thing we have to note is that at 4, 0 and -4, 0, the derivatives are -3 and 4. Sorry, -3 over 4. So the derivative at -4, 0, which is approximately here, is going that way. It is, I don't know, approximately something like that. And that makes sense because the -4, this eigenvalue, is the bigger of the two eigenvalues, which means the solutions move along this eigenvector. So they're actually going to come along, and I'll actually start out over here from -6. So they come along here, down through there, and as they reach this second eigenvector, they go in to 0, 0, like so. I could draw another one over here. Comes along here like this. Guys, again, I always apologize. My ability to graph with this pen is difficult, but you got to put the arrows on this as well, guys, because it's going in towards 0, 0. Now they say, if you check the mark scheme, it says they only want 3, at least 3. It says I'm going to put more than 3, and I'm going to put some into each different kind of section. But again, at 4, 0, yeah, this is the next point. At, because it's 4 marks, is the next mark. At -4, 0 and 4, 0, which is approximately here, you should have a gradient of approximately -3/4, which is at least, it's negative. It's going down like this. It's going down like this. So this guy, again, he's following the, he follows in the direction of the eigenvector until he gets to this second eigenvector, and then he kind of just goes in towards 0. I'm going to put an arrow there again. Let's do another one of these. Something like that. I'm also going to put one in here, guys, even though these will essentially kind of look like straight lines because they're just going to come in like that. That's not a great. Actually do a straight line, so it goes in like this, and then in towards 0, and then this guy will come in like this, and then in like 0. Anyway, guys, I'm sure you get the point, and you could probably do a better line. So that's it. That's definitely enough. Like you get one mark for drawing the two eigenvectors. Make sure you have the arrows. You get another mark for having a negative gradient at -4, 0, and 4, 0. You get another mark for having at least three trajectories. I've actually put in 6 here, and I think the final mark is that they go in towards 0. So you got to put the arrows on each of the trajectories. Okay, that's it, guys. That's the paper. I'll see you for paper 3.